Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 42 in our incredible new tutorial series where you're teaching your Raspberry Pi who's boss. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this excellent series of video tutorials, and in this class we will be using the Sunfounder Raphael kit for Raspberry Pi. The Sunfounder Raphael kit. Now, most of you guys probably already have your gear. If you don't have your gear yet, look down in the description. There is a link over to this kit, and you can pick one up for yourself at Amazon. And believe me, my life and your life are going to be a whole lot easier if we are working on identical hardware. Okay, enough of this shameless self-promotion and advertising. Let's jump in and talk about what I am going to teach you today. And what I'm going to do is I'm going to show you my solution to the homework assignment that I gave you in lesson number 41. And that homework assignment was to create a simple client-server system based on the Raspberry Pi. The Raspberry Pi is supposed to sit there and make temperature and humidity measurements at the command of the client. So the Raspberry Pi is the server. It is able to make temperature and humidity measurements. When the client asks for a measurement, the Raspberry Pi runs out, makes the measurement, and then sends the data back to the client. Let me start by asking how many of you guys were successful. If you were successful, leave a comment down below. I am legend, double chest bump. And if you were not successful, leave a comment. I folded up like a cheap Walmart lawn chair. So you guys, let me know how many of you were successful. This should be pretty straightforward because in lesson 41, I showed you how to pass data back and forth using UDP. And so I sort of showed you the skeleton, the nuts and bolts of how you actually pass the data. And now with just a little thought, you ought to be able to create this simple client-server type relationship. Okay, so if we're going to do this, the first thing that we're going to need to do is we are going to need to hook up the Raspberry Pi to the DHT11. And I will remind you that I showed you how to do this in lesson number 25 in this class. And this is how I did it. And then this is the schematic over here. And so it's a very simple, just very few number of wires that you need to get this thing hooked up. You should be able to look at this and do it. If you need more help or more explanation, go back to lesson number 25. But I don't want to spend too much time on that because I want to jump over here. And I want to jump over here, and I got to do one little bookkeeping thing here to get my windows right. Okay, I need to come over here. This is the PC window, and so we're going to start with the server. The server's on the Raspberry Pi, so we're going to code up the Raspberry Pi first. I hope that makes sense. Now you see that we're using the DHT11, and if you guys have not done this already, you need to install the DHT11 library, and you can do that in a terminal by just typing pip3 install, and I want to install the DHT11 like that. And then when I do it, it's going to say that it's already installed because I did this before, but when you do it, it will take maybe 30 seconds to get the library installed, and then you will be right where I am. Okay, so let's start over here and let's start coding up our server. Well, if we are going to create a server, what library do we need? We are going to need the socket library because the socket is what connects the client to the server. So we are going to need that library. I always like to import time because it seems like I usually need to put a few delays in here or there. We're going to be interacting with the DHT11 through the GPIO pins. So we will need to import rpi.gpio as GPIO like that. And then we're going to need to import the DHT11 library. that allows us to make the temperature and humidity measurements. Now we are going to be interacting with the DHT11 through the GPIO pin, so we need to set those up, GPIO.setMode. And what do we want to do? We want to do GPIO.BCM, and that way we can use the BCM numbering system. Why do we do that? Why do we do that? Because this is labeled, the breakout board here is labeled in the BCM numbering system. And so that just makes life a little bit easier. So we're going to do the set mode, and then I need to create my sensor object. So I will say my DHT is equal to DHT11, the library, DHT11, the method. And then where am I? If I look closely at mine, I'm connected to BCM pin 27, like that. Okay, so now the sensor is set up. Now let's go ahead and do a little bit more work in getting our server set up. So first thing is buffer size. And so we need a buffer to put the data to send back and forth. Let's make it plenty big. It doesn't have to be exactly the size of the data, but just make sure it's big enough to hold the data. So we will oversize it to 1024. Now we need to have the server IP. What is the server IP? The server IP is the IP of your Raspberry Pi. Why? We said the Raspberry Pi was going to be the server. So I can do a ifconfig here, ifconfig, and I am hooked up over Wi-Fi, and so I can come down here and I can get my IP address there. I wonder if I can even copy it and then come over here. And then I'm going to put it in single quotes, and I will paste and close the single quotes. This is my IP address. You don't use my IP address, you use your IP address. That's a little pro tip there, okay? Believe me, there have been people that have failed because they tried to use my IP address instead of their IP address. Okay, we're also going to need to set up the server port. Just use a port that's not in use. I'm going to use 2222. And I want you to see that no quotes around the 2222. All right. Now I'm going to go ahead and create my server object. So I'm going to say RPI server is equal to socket the library above dot socket the method, and now I've got to set this socket up for UDP, and I showed you that last week. We do it with the command socket dot AF underscore INET. Okay, AF underscore INET, and then socket dot SOCK underscore DGRAM, like that. That should set up our Raspberry Pi server. Now, once we've done that, we've got to tell the server where it should be listening. So I need to take the server RPI server, and then I need to dot bind it. And where do I bind it? Well, I bind it to my server IP and my server port, but understand that it wants a tuple here. So I need to come back and I need to open the parentheses again to start the tuple, and then I need to close the tuple, and then I need to close the command. So this will tell my RPI server to look at its own IP address to be listening there at port 2222, if that makes sense. I hope that makes sense. So now my server is up and pretty much ready to go. And so I think I'm just going to print at this point. I'm going to print server up and listening. Okay, at this point it's all set up and it's going to be waiting for data. So what I want to do is this time I don't want to just go out and get one command. I want to constantly be listening for a command. If there's a command, read the command and then do what I'm told to do. So what I'm going to do is I'm going to set that up in a while loop. I'm going to say while true. When is true? True. True is always true. So we're creating something of an infinite loop here. And then I'm going to go out and I'm going to try to read the command cmd. And then when I get that command from the client, that client is going to send me his address. This address is the address of the client that the client is sending me with his request. So I'm getting the command, what he wants me to do, and I'm getting the address where he is. All right. And so how do I actually do the read? Well, I go to RPI server like that, and I do a RECV, receive from, and then how big of a buffer, BUFFERSIZE. Okay. And so that is going to sit at that line of code until some client on my network asks or sends a command. And so it's going to sit here until it gets a command. When it gets a command, then it is going to read. Okay, when it gets a command, then it is going to read. Now, once I read it, I need to decode it. So CMD is equal to cmd.decode. And then how do I decode it? Well, I use our old friend UTF-8, which we've talked quite a bit about. Now I have the command in easy to use, in easy to read mode format. And so let's just print it because that might help us with the debugging later. So whatever command we got, let's just go ahead and print out that command. Okay. Let's also print out the address. So this is what they want, command, and who is it that's asking? Well, let's look at the client address. So I'm going to say client address. This is who did the asking, and that is going to be that address that I read, and it is going to be at location 0. So location 0 is the IP address, and location 1 is the port. But I'm just going to look at the IP address. All right. So now we've got to decide what to do. Well, if the command is go, I'm going to go out and I'm going to make a reading of temperature and humidity, and I'm going to send it back to the client. So if the CMD is equal go, I'm going to do certain things. The first thing that I am going to do is I am going to read the data. So I'm going to say I'm going to read the sensor. So I'll say the result of the read is going to be DHT. It's going to be my DHT dot, it's going to be my DHT dot read like that. And so that goes out and does a sensor read. Now what I can say is data is, I'm going to create now the data. So when I do that read, I have got the, when I do that read, I have read temperature and humidity from the DHT11. But now I've got to decide, is that valid data or is it not valid data? Because about 25% of the time, the DHT11 returns a, not good result. So I only want to use the data if it's valid. So I'm going to check that. If result.is_valid, if the result was good, then what do I want to do? I want to create the data string that I return to the client. So the data is going to be the string value of what? Result.temperature, right? It's going to return a number like 26, but I want to send a string back. It's going to say the data is the string value of result.temperature, and then I also want result dot humidity. But if I'm sending two data pieces, if I'm sending two pieces of data in this packet, I need to have a delimiter. So I'm going to use a delimiter of a colon. So I'm going to add to my string the character colon, and now I'm going to add to my string the string value of result.humidity, like that. Okay, so I've created the data packet that I want to send back. Now I got to convert it to bytes. So I'm going to say data is equal to data.encode. We encode it with the UTF-8, like that. Okay, I've got the data. Now I'm going to send it RPI server dot send to. What do I want to send? That data, that encoded packet of data. Who do I want to send it to? Whoever asked. And I got the asker's address up here, so I just send it back to who? To address. All right, so that takes care of that. Now we've got to ask ourselves the other case. If result.isValid is equal false, what happens if the sensor tells us, hey, I just sent you bad data? What do we do in that case? In that case, we're going to say that the data is equal to bad measurement, because we want to send something back. We want to send something back to the client, and what would just send back is, hey, I didn't get data. So I would say, I would send back that. Let's go ahead and print that out on this side just so that we can see it. Now let's data is equal to data.encode with the UTF-8, like that. And now let's send it. RPI server dot send to, and then we're going to send that data back to the requesting address. So it might get data back, or it might get the string that we didn't get data, we got bad measurement. And then the client can decide what to do when there's no data there. All right, now the other possibility here is those are the two possibilities if the command is go. But if CMD is not equal to go, well, go is the only command that we've got. And so if the command is not go, then we just need to say data is equal to invalid request. Now later we could give it a different command, like instead of just, you know, go, we could ask for pressure, or we could ask for the internal core temperature of the pie. We could ask for something else and it could do that. But right now the only valid request is go. So if the command is not go, then the data is invalid request, and then data is equal to data.encode UTF-8, not forgetting the quotes around that, like that. And then what we are going to do is we will come in and we will send that. So RPI server dot send to, we're going to send it to data and address. So what are the two cases? Either it got a good command or it did not get a good command. If it got a good command, either it made a good measurement or it didn't make a good measurement. And I think this is pretty much what we need. Before we jump over and start working on the client side, let's see if this thing will run. And so I'm going to just run this, just checking. And what you can see here is, if I turn off the title ever so briefly, what you can see is it says the server is up and listening. So at least I didn't get any grotesque errors. And so at this point, I think that we can jump on over to the client side. And so now this window that I'm opening up, This is on my PC. This is idle, or whatever integrated development environment that you want to use. Maybe you're using VS Code. I'm just going to do it in idle because I just want to crank this thing out. So we are over here now on the client side, and so we're going to need to talk to that socket. So we're going to need to import socket. So we are going to come up and import socket, just like on the server side. The client needs to import socket. Always a good idea to import time. Now I need to set up the server address. And I'm going to go ahead and set it up as a tuple. And the server is who? The server is Raspberry Pi. So whose IP address should I put in? The Raspberry Pi's IP address, which was 192.168.88.41, like that. And then I also need to give it in that tuple, I need to end in the IP address, and then I need to give it the port, which was 2222. All right, now this is where people get confused because they want to do the analogy on the client side to what they did on the server. On the server side, the server put its own IP address in. On the client side, you don't put the client IP address in, you put the server IP address in. And I think that's where a lot of people get hung up. But if you do it this way, this is the right way, and I promise you it will work. So now we're going to come in and we're going to say buffer size. And what did we make that? We had made that 1024. And so let's get that matched. And now I'm going to create the client. So I'm going to say the UDP client object is going to be equal to socket the library dot socket the method, and now the same thing we did a while ago, socket and then dot AF underscore INET, like that, and then socket dot sock underscore DGRAM. Okay, so now that should set up the client. You don't bind on the client side. You just go out to the IP address. You don't bind this client to a specific server. You can talk to whatever server you want as indicated by the server address. So the server is bound to its IP address. The client is, you don't do a bind on the client side. Okay, so we've got the buffer size, we've got the UDP client set up. So now I think we're ready to begin to ask for data. So I'm going to say while true, when is true, true, true is always true. And now I'm going to create the command. The command is going to be, what's it looking for? Go. And so I'm going to create the command go, and then I am going to encode the command, and I'm going to encode it with, you guessed it, UTF-8, close it, close it. It's encoded now, UDP client dot send to, and then what am I going to send? I'm going to send the command that I just encoded. Who am I going to send it to? Server address, like that, which we defined above. All right, now I've sent a command. Now what do? I sit and I listen and I wait for the data to come back. And so I'm looking to get my data and the address that the data is coming from. Even though I know it's the server, I've got to give a variable there for the data to come into. I won't need to use that because I already know what it is. But what are we going to go to? UDP client, like that, UDP client. And then what am I going to do? I am going to go to UDP client, and then I'm going to dot, let me get that out of the way. I'm going to dot recv from, receive from, and then again I just need to tell it the buffer size, like that. Okay, now I've got to decode the data, so data is equal to data.decode using UTF-8, close it. So I now have the data decoded. Now, what you need to see is I sent temperature, humidity. So I'm going to have this long string. I need to kind of parse that string now. And so I'm going to say data array is going to be equal to the data that I have, but I want to dot split it. And what do I want to split it at? The colon. And now this will give me an array. The first element of the array will be the string value of temperature, and the second value in the array will be the string value of humidity. So I want to split on the colon. So now I have an array. Now, if it was invalid data, if it was a bad measurement or an invalid command, there will be one element in this array. So I'm going to say if the length of data, array, if the length of that is equal to 1, then what do? I just print. For whatever reason, there's no data. Like that. But if the length of data array, if that's equal to, that means it sent me temperature and humidity. Everything is good. So in that case, what do? Well, I need to print it out. So I'm going to print temperature in the string, comma, and then what? Data array element 0. And then I want to print, humidity as the label. And you can't see that, can you? Okay, so then that is humidity, and then comma, data array, data array 1 will be humidity. Close the index and close the print. And then let's just see who it, again, well, I already know. I know that it's coming from the server, so I'm not going to print those things out. And then what I'm just going to do is I am just at this point going to do a time.sleep of 1 second, just so that we're not getting the data coming in too quickly. Okay, does this make sense? Who is in control? The server is in control. The server is going to come in, it's going to create the command go, it's going to encode that command, it's going to send that command to the server. The client is going to send that command to the server, and then over on the server side, it was just sitting here waiting for a command. It was sitting here waiting for a command. And then when it gets the command, it breaks it apart. If it is a valid command, go, and if it is able to read the temperature, then it is going to send the temperature and humidity back to, it is going to serve that data up back to the client, and then the client is going to read it, break it apart, and print it. Okay, so let's come back over here to the server side, and then I'm going to stop it, and then I'm going to run it. I don't get any errors on this side, on the server side, so I'm going to move back to the client side. And then I'm going to come up here and I'm going to try to run this. Now, I could have all types of typos on this side, so I have no idea what's going to happen. Yeah, let's go ahead and save it. And it says I've got an error in line 9. UDP client send to bytes like object is required, not string. So let's see what the problem is here in line 9. It's as if I didn't, encode command. I see. Did you guys see that? Very, very silly mistake. I needed to say cmd equal cmd.encode. All right. So now we are going to try this again. We'll come up and we will run it. Okay, so it's running. I'm getting no data, and boom, look at that. Temperature 27.1, humidity 62. Okay, look at that. Now, if we come back over here on the client, on the server side, and we turn the title off, what you can see is that it's getting the go command, and then it is taking the measurement, and if it's a bad measurement, it says bad measurement, but then if it's good, it just goes ahead and sends it. But like I say, you can see that about a fourth of the time, it's not getting a good measurement. I am really not sure why we aren't getting better, why we aren't getting more good reads from the DHT11, but you can see that it recognizes, so at least it recognizes when it's not getting a good read. Okay, this is just pretty darn cool. You have created your first client-server system or relationship. The client is the PC. It sends its request to the server. The server receives the request and then responds back. Now, what you can see here is that the approach that we took is to just have one command go. It just has one command go, and then it responds with the temperature colon the humidity. All right, but really you can think about it is you want to probably in a lot of things you want to have more than just one command. And so what your homework is going to be for next week is to take this code and do some tweaking on this code. And what I want you to do, you can keep the same circuit as we have down here, but I want a different client-server relationship where on the client side, it's sitting and it's asking the user, what do you want to do? And if the user types in temp, then the client sends the command temp to the server goes out and gets temperature and just returns temperature. If the client is sitting there asking the user, what do you want to do? And he types in humidity or hum or whatever you want the key to be, then the PC, the client will send that to the Raspberry Pi. The Raspberry Pi sees that humidity is being requested, humidity is measured, and humidity is sent back. So now we have two commands. The command could be to do temp or to do hum, temp or hum, and the measurement it makes in the data that it sends back depends on what the command is. Does that make sense? I hope it makes sense. Okay, guys, man, I hope you're having as much fun taking these lessons as I am making them. And this is really pretty big deal stuff. This is pretty big boy stuff that you can go in and with your Raspberry Pi starting from scratch, create a server out of it and then access that server from clients that you are creating on your PC. I think that is just really neat. You guys, don't forget, you need to be posting your homework solutions to YouTube. When you do that and you leave a comment in the, you leave a comment, a link in the comments below over your homework assignment, your homework solutions, I go in and I look at every single homework solutions that you guys submit and I'll make comments on them. And so make sure that you do that. When you post your homework, make sure in your description you leave a link back to this video, and so people will know, they'll have context and sort of know what you are doing. That's your homework for next week. In next week's lesson, I'll show you my solution to that. I'll give you a few extra extra things to think about how to make good sort of a little bit of fault tolerance in the way that you do this. Okay, so we'll learn a little bit in next week's lesson, as well as I will be showing you my solution to this homework. Guys, I hope you are having as much fun taking these classes as I am making them. If you enjoyed the video, make sure that you give it a thumbs up. If you have not already, subscribe to the channel. When you do, make sure you ring that bell so you will get notifications for future lessons. And share this with other people. Share this with your neighbors, young people, your family member, because the world needs more people doing coding and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.